Right, this is the third video in a series of three talking about finding trig functions at any angle. And really, this one's actually going to talk a little bit more about going backwards. But in order to do that and make it make sense, we want to talk a little bit about reference angles again, as well as how we can, again, draw out those reference angles to help us understand why there might be more than one answer to today's kind of question. So first of all, we just want to review very quickly. Again, if you're talking about a reference angle, we're talking about the angle directly to the x-axis formed by any angle. So if you're looking over here at 634 degrees, the first thing that I would do is subtract 360 degrees from that angle. So again, very quickly, I've got this prepped on my calculator. So I'm just going to call that up real quick here. So we'll notice 274 degrees essentially is what we'll end up getting. So 274, whoa, I'm not sure what that was, but 274 degrees is our angle. Well, that means that we're going essentially around here and about 4 degrees past, again, 270. And remember that the reference angle, again, will just be this leftover portion. So again, I'm going to want to take 360 minus that 274 and see what that remainder comes out to. So again, let's go ahead and hop onto the calculator. 360, right? Not typing smoothly here today. 360 minus 274, and we'll end up with 86 degrees, which very simply is then our reference angle, right? Now, the same thing can happen in radians. It's actually a little bit quicker and easier, really. 10 pi over 5, or 10 fifths would be 2 pi. So if we subtract, again, 2 pi, we're really saying that this would be 8 pi over 5 then, right? We're subtracting 10 pi over 5. And 8 fifths, again, is 5 fifths, which would be 1 pi, plus an additional 3 fifths. So again, taking around 3 fifths, a little bit more than halfway. So again, we technically went a full circle, plus 5 more fifths, plus 3 more fifths, and we ended up down in this area, again, down in quadrant 4. Well, if this portion, again, is 3 fifths, then the portion left over, right over here, must have been 2 fifths of pi. So again, that's our reference. Now, where can we use that? Well, why do we care about that? Well, similar to the idea over here at the right. If I want to find the cosecant of theta, one of the easiest things to do is take my formula here, and let's draw ourselves a triangle in one of the quadrants. I know that the cosine is negative to the left, because cosine is much like an x-coordinate, right, on a unit circle. So I'm going to draw a triangle out to the left out here. But now I also need to know, well, am I going up into quadrant 2 or down into quadrant 3? And that's where this will come into play. Tangent is positive. Again, if we remember our old SATC, if that helps, all things are positive in quadrant 1, only the sine, only the cosine, only the tangent down in quadrant 3 there. So the tangent would be positive at this triangle here. So I'm not worried about the one I could draw up in quadrant 2. I'm going to go left 4 units, right, adjacent, hypotenuse of 5, and if you're familiar, 3, 4, 5 triangle. Again, we can do a little Pythagorean theorem, but just trust me, again, that's going to be a 3, 4, 5 triangle there. If one leg is 4, hypotenuse of 5, 25 minus 16, square root would be 3. Again, a little Pythagorean theorem, we got that negative 3 going there. We're going downwards, so it's got to be negative. Well, in that case, the cosecant of theta, remember, is equal to 1 over the sine of theta. The sine would have been negative 3 over 5. So again, the cosecant should be equal to negative 5 over 3. Because again, we can use that reference angle, right? I'm not worried about the full angle drawn out. It's really the reference angle where we get our triangle from. Now, let's quickly move into kind of our goal for today. The idea here is, what if they asked me to find the actual angle? What if they actually finally asked me to find the angle, not just the trig function? Well, notice in the problem on the left, it says, let's find it in degrees. So just keep that in mind as we're working. We want to make sure we're working in degrees. But I kind of recognize that number. Root 2 over 2 makes me think of 45, 45, 90 triangles, right? 45, 45, 90 triangles. So in that case, I'm not going to hop on the calculator for this one. I'm thinking we could solve this pretty quick and simple if we just think our way through. Where would the cosine have been a negative root 2 over 2? Again, the old SATC, cosine is typically our x-coordinate. It's going to be negative to the left. So again, I should have a triangle out here in quadrant 2 and another angle here out in quadrant 3. both of which should have a root 2 over 2 sort of ratio to them. Well, that makes me think, again, 45, 45, 90 triangle, right? If we did 1, 1, square root of 2, again, the adjacent over the hypotenuse, 1 over root 2, and notice it would have been negative 1, over root 2, right, is the same thing as root 2 over 2. Which means I'm thinking, okay, well, I want that angle, right, if we draw them both separately here, I want the angle that would take me from 0 into quadrant 2, leaving a 45-degree reference angle, and I want the angle that would take me all the way down into quadrant 3, again with a 45-degree reference angle. Well, in degrees, this angle would be 180 minus 45, or basically 135 degrees. And down here, it would be 180 plus 45, right? Or basically 225 degrees. And we've got our answers, right? Again, when we're looking at 30, 60, 90 triangles or 45, 45, 90 triangles, don't use a calculator. Just draw yourself a picture, right? Draw out that 45, 45, 90 triangle and see if you can identify which angles you're looking at from the positive x-axis. Remember, the angle we're looking for, in order to be a negative ratio, needs to measure from 0 all the way around. So let's do that same thing over here at the right. Now the downside is I don't know that number is not a number I'm familiar with. I don't know when the sine of theta equals 0.437. That's definitely not a root 2 over 2. It's not a root 3 over 2. It's not a 1/2, right? It doesn't look like a 30, 60, 90, 45, 45, 90, or one of those quadrantal angles, right? One of those zeros or ones. So therefore, my best option is let's hop on the calculator. In order to get theta all by itself, remember, we're going to take an inverse function. If we have the sine of theta on the left, let's take the inverse sine, right, of our value on the right. So again, we're going to hop on the calculator. Now you'll notice, again, we want to be in radians for this one. We don't have to be in terms of pi. Again, the answer I get back is going to be an angle, but again, it's going to be a decimal value. I'm not worried about being in terms of pi. I just want to be between 0 and 2 pi, which our first answer definitely will be. So let's take the inverse sine, second sine here, right? Use that inverse sine of, again, 0.437. 0.437. And again, I'm going to close that off, press enter. However, I was in degree mode. Notice it's about 25 degrees, a little more than 25 degrees, almost 26. I need to change my mode first, though. I'm going to go down to mode. I'm going to put it in radians. So now you'll notice up top I'm in radian mode. So second quit. If I just hit enter again, so 0.452 looks like a good answer. 0.452. And again, that's in radians, so I don't really need to label it there. Now that's definitely between 0 and 2 pi. Remember that 2 pi is about 6.28 here, right? Pi again being 3.14. So again, 0.4 is really a quadrant 1. Remember how we said it was about 26 degrees. What I want to remember though is the sine of theta, right? The sine of an angle can also be positive up in quadrant 2, right? Sine is like the y coordinate on a unit circle. So again, it's positive in quadrant 1. Everything's positive in quadrant 1. But the sine, right, SATC, right, I always like to reinforce that nice shortcut. Sine is also positive in quadrant 2. So again, we're going to have an answer somewhere out here. And if we know that our reference angle is 0.452, then this angle over here, right, is going to be 0.452. What I want to know is what's this angle. So again, if this is pi over here, best thing we can do is take pi minus 0.452. So we'll hop on the calculator here one more time. Pi minus, and again, best thing I can do is probably just go up here and copy my answer down. More decimals always makes for a more precise answer. And we get about 2.689. Looks like 2.689. So again, I can say or 2.689. And again, both of those answers, right, from 0 to 2 pi in that first full circle, right, those are the only two possible answers where sign would have been positive, because it's only positive in quadrants 1 and 2 in order to get us this number. Again, if you have any questions about that at all, talk to your teacher. Otherwise, think about those positives and negatives when you're solving those equations. Again, if we're going a full circle, there's a good chance that there's two different answers, right? Two different quadrants where these answers occur. Not always, but much of the time. Have a great day.